So you have so one step ahead forecast, everything is plus 1. So this one t plus 1, t minus 1 plus 1. Okay, so become t minus 2 plus 1, so t minus 1, t minus 3 plus 1, t minus 2, t minus 4 plus 1, t minus 3. And then you refer to the value of y. So this one, the last observation of y, the last observation of y is given in the table. So yt. So this is the yt. The last observation is yt. The last one is the last in sample is yt. The second last is yt minus 1. The third last is yt minus 2, and so on. Okay. So using this value, you plug that value into these equations. Okay, then you solve. So you put the value the yt minus 1, yt minus 2, yt minus 3. You solve it. You get forecast for one step ahead. Two-step ahead forecast. Two-step ahead forecast. You from here. So you from the Victor equation, everything is plus 2. So t plus 2. This one t minus 1 plus 2. It is t plus 1. T minus 2 plus 2. It is t plus t. Okay, t minus 2 plus 2. So it is t yt. T minus 3 plus 2 is t minus 1. T minus 1 plus 2, t minus 2. Okay. And then you again refer to the table. So this one, yt plus 1, we don't have our sample value in the table. We don't have t plus 1 here, but we do have forecast value for t plus 1. Just now, we have forecast value for t plus 1. So we can use this value, forecast value, to calculate forecast for t plus 2. Okay, so this one, we use the forecasted value. This one, we put here. And then the other, we use the base from table. So yt minus 1, yt minus 2. And then t minus 3 step ahead forecast also the same, the step. So everything is plus 3. So you can see that for this one, we use the previous forecast value at time t plus 2. This one, previous forecast value at t plus 1. And then this one, last value of y, second last value. Okay, so we get this forecast. Alright, number 3, 4 and 5 we are using the same data, but we apply different models. So the time the data given in the use file. Okay, now you open the data, you use data Q3, Q5. Okay, so this is your data. Assume that y is already stationary. Remember, the first step, you have to examine your data whether it is stationary or not. You need to make sure that the series is already stationary. If the series is not stationary, we have to transform the series. For example, through the use of differencing, for example, in order to make it stationary. But the one we haven't discussed, the one we discussed, the real test we discuss after the test. The next 2 weeks. So again, the data, if we check the data, so this data, you check the graph. So the data, what is this graph? Okay. So this one, you see that basically around zero, the mean around. So we expect that, we can expect that the mean, the constant is going to be our mean, the C introduced is going to be insignificant. So now, what model we can propose for this series? So you need to check the chorogram, view chorogram, level original series, level original series. Okay, so just use the default one. So include 12. So now we want to propose suitable model. So you inspect the first few legs I mentioned before. So you can just normally just up to 5 or 6. Depends lah. You have monthly data, or I mean, if you have data which is not quarterly, and then we can use up to 6. Normally lah, but you have quarterly data, just up to, for the seasonal one, normally just up to 3. But if you want to include, but in that case, you have to include the seasonal component lah. By one we have one also we haven't discussed. But normally just up to 5 or 6 lah. Normally we just set. Okay, if you do not include seasonal component, then it's up to 5 or 6. So this one, if you refer to this sample ECF and sample PCF, and then you recall back what you have, what we produced before in lecture 7 in terms of the theoretical ACF and PCF for moving average process as well as auto receive, and then this one consistent to which one? Okay, if let's say you assume that this is the one that exponential decay. This one sample, remember, it's not the true one. This is a sample ECF, sample PCF. So we just use this to make us make a guess what is the pattern, the most likely pattern for the true ACF, the true PCF. Okay. So if you consider this as the one that decreasing exponential decay, and this is significant at leg 1, significant at leg 2, and then cut off to 0, or spike at leg 1, spike at leg 2, cut off to 0, then we are able to propose what model? MAOAR. Still do not know. MAOAR. If let's say you say this is the one that decreasing, this one is spike at leg 1, spike at leg 2, cut off to 0. MA2 lah, MA2 lah. Okay, if they say this is, so you refer to the lecture sample, the table, huh? So next week is our proposal, so you can refer, even final exam also proposal. But you are not allowed to discuss, huh? Do not share your answer with your friend. Huh? Okay. You share your answer with your friend. You are making yourself difficult to get good marks, because normally we will not allow all students to get A, for example. If all get high mark, then we start to find way so that not all get A. Right? So don't share your answer to your friend if you are very good. Do not share your answer to your friend. You are making yourself difficult to get A if you give your answer to your friend. Okay. So this one, if again mentioned just now, so you refer to the table. So this is consistent. You say this is the one decreasing. So this one is spike at 1, 2, cut off to 0. So it is MA2. Okay. If let's say you want to propose two model, another model. Okay, if let's say the possibility, and this is the one that there's possibility that the true ACF is the one that decreasing, and this is the one that spike at 1, 2, and then you also can propose R2 lah. Okay, but again, if you just want to propose one model, what model you should suggest, and then you refer to this one. So meaning that you check which one is the one that decreasing. So in absolute value, this is decreasing. This one not really, because the second one higher than the first one. Yeah. Okay. But again, if only one, then you propose based on that. If you only want, you want to propose two, then you can propose both. Okay, MA2 or AR2, you can try both, and then you compare AIC or SIC, and see which one has smaller value. Okay, so now let's say MA2 first. So this one, the question number 3. Okay, MA2, And based on graph just now, it just fluctuates around 0, so it's quite unlikely C to be significant, but we can try to make it reverse. So we estimate a model. Maybe we can delete this one first. Delete. This one as well. Okay, now to estimate MA2 model, you go to quick estimate equation. So you have y space. Just put C first. See what is significant. C, MA1, MA2. Okay, so just press OK. You see that C is not significant, so you can remove C. So re-estimate, I remove the C. Okay, so now we have already estimated the model. So what we have here, this one gives us estimate for theta 1. This estimate of theta 2. This estimate of the sigma square. Remember, epsilon is a Wiener process, remain 0 and sigma square. So this is the estimate of the sigma square. Okay, so the next step what you need to do, you check whether the model is invertible because we have moving average. So we have pure MA. So we just need to check whether the model is invertible. Remember why? Why we need to check? Because we need to make sure the model has an equivalent autoregressive representation. So that meaning that we are using, if it has autoregressive representation, that meaning that we're still using the previous value of y indirectly to produce forecast of the future value of y. Although in the model itself we only have error term, but since it has equivalent autoregressive representation, then meaning that we actually indirectly use the previous estimate, the previous value of y.
Doctor, so in estimation for an MA model, do you actually use OLS on the previous y value, or use a different method?
For the when we have moving average component, we cannot use. We can use this pair, but in terms of estimation, it's unlike regression. Regression we can use formula, but this one because have error, so error need to be, so it needs to use iteration. So you use iteration. You see that's when it has iteration, meaning that it just like optimization. So you need to assign a value in its initial point, initial value, and then it keep find other value that give us smallest value of depends on this one. Maybe is when we estimate. It's like it perform estimation based on maximum likelihood. So basically, you can choose different. This one is maximum likelihood. It doesn't mention whether it's based on AIC or SIC. Okay, so you need to check whether it's invertible or not. How to check? You go to view, ARMA structure. So you can either check the graph or table. So table is quite straightforward. You can see it has a statement whether it is invertible or not. But graph you have to check whether the inverse of the inside or outside. But we need to be inside. Okay, we need to be inside. So if you check again, you check table, and then this one it says that no roots lies outside unit circle, so the model of our model is invertible. So easy lah. If you look at this one, but you should understand why. Okay. So the next thing that you have to check is the residual. Perform the diagnostic checking on the residual. You go to view, residual diagnostic, program Q statistic. Okay, let's say default 36. Okay, now, so you actually, now we need to check the residual. You can perform the joint harvest testing instead of checking one by one. It's easier to perform the test using joint harvest testing, meaning you're testing auto correction at leg 1, leg 2, up to leg M. So M is, you normally just take the square root of observation. Okay, so it depends. Basically, there are other suggestions. I mentioned before now. So the textbook is just different. It provide different suggestion on what is the value of M that you should use. But another suggestion is just use. It says that do not perform the test beyond the square root of sample size. Okay, otherwise after that it is less reliable. It's no longer reliable. So they say we just use that one. So square root of 146 about 12. Okay. So you perform the test at leg M, meaning that we are testing what? We are testing autocorrelation between the error at time t and t minus 1, and between error at time t and t minus 2, minus 1, t and 3 minus 3 and so on, up to t and t minus 12. So then the Q statistic is given 8.3, p value 0.599, so we do not reject. Okay, based on p value, we do not reject. So the conclusion is that autocorrelation within the residuals, okay, leg 1 up to leg 12 all equal to 0. So the conclusion is that we are confident to say that the true value of autocorrelation between epsilon t and epsilon t minus 1, epsilon t and epsilon t minus 2, epsilon t and epsilon t up till t minus 12 all equal to 0. So residuals, in this case, the error term, we use residual as estimate for error term. So then we conclude that the error term of this model is our white noise process. The residual disturbance are our white noise process. So then the model is adequate and we can use it to produce forecast. Okay, so to produce forecast using eViews. So you go to forecast, YF. Okay, let's see ME2 just now. SE, ME2. Forecast, for example, forecast range, let's say, because you here we use data from until 146 to 147 until 150. So let's say we use forecast range for observation. Okay. Alright, that's okay. So you have point forecast and then interval forecast, approximately 95% because just plus minus 2 times SE. So if we make assumption that the error term normally distributed, then we should use 1.96. But this one just we use 2 times SE. So MEPE given here. So do we have the actual value here? Y for our sample, do we have it? 550. So good forecast, we consider as good forecast less than 10%, only greater than 10%. This one 97.5%. But we only have 4 observations here. Okay, forecast value given here, YF MA2 is your forecast value lah. Okay. Let's check whether the answer given is the same. Just afraid that I put the correct range of data. 0.05. Okay. 1 step ahead, 2 step ahead, 4 step ahead. Your standard error, forecasted error given, forecasted error is given here. Okay. Okay, this is forecasted error. If you were to calculate manually, what you need to do, you have to determine your forecast equation first. So based on the estimated value, we don't have C, so we have, so this is a fitted value at time t, yt the fitted equation, so theta 1 hat, theta 2 hat. So residual you can get from here. So residual is given after we estimate model. Just now, this is our model. This is our estimated model. So residual can be obtained from here. Okay, basically we have this here, but this is this receipt is stored residual of the last estimated model. To be safe, we take from here. So actual fitted residual table. So we have residual. So the last residual are given here. Okay, the last residual. So we have 0.45 and so on. So you have, if you want to calculate manually, then you have to identify this equation first, forecast equation. For 1 step ahead forecast, you have to add 1, t plus 1, everything plus 1. So this one you can see that this one you can use the last residual. This one you can use the second last residual because t minus 1. Okay, so you can take the residual, the first, second last residual to calculate. Okay, so to calculate. So if you calculate, so we have the last 4 observation of y, the last observation of y example, this one. So this one I already provide you the Excel file. So we have observation of y, the last 4 observation, yt minus 1 and so on, and then the last 4 residuals, and then we can calculate. So we can calculate using the identified equation just now. So you calculate, you can use 1 step ahead forecast, 2 step ahead forecast. So 2 step ahead, everything you plus 2. So and you identify which one we can calculate. So if everything is plus 2, so this one t minus 1 plus 2, it is t plus 1. So we cannot. So this one t minus 2 plus 2 is t, so we can use the last residual. Okay, the last residual. So you take the last residual, you calculate, so you get this 0.158. Okay, and then 3 step ahead, everything plus 2. So this one t minus 1 plus 3, not everything plus 3. So t minus 1 plus 3, so it is t plus 2. We cannot. So this one t minus 2 plus 3, so it is t plus 1, so we cannot. So it is converted to 0. So both are, we just replace with 0. So 0. And then the 4th step ahead also 0. So you can see that it converts to 0. So in terms of the calculation like this now, so you get SE just now from you use SE, and then you can calculate the lower forecast interval as well as the interval forecast and upper interval forecast. 95% just 1 point forecast plus minus 1.96 times SE. Okay. SE I will not ask you to calculate manually because it's not that easy to calculate. So you can just get from use. Okay, SE just now. Okay, now if let's say we consider the possibility that the ACF is the one that decreasing or exponential decay, so meaning that we propose AR2, we can propose AR2, now we estimate R2. So to estimate R2, so this one maybe I close and save as we name as MA2. Now we estimate another model, so quick estimate equation. Okay, estimate equation. So we have y space c is, I mean, it's going to be insignificant, only equal to c. So in R1 and R2. Okay. So that's okay. So for this model, what are the things that you need to check? You need to check whether it is stationary, not invertible. So moving average determines the invertibility. Invertibility, autoregressive determines the stationarity. So you have to check whether it's stationary or not. But you look at the inverted arrow given here, quite clear that it is inside. Both are inside the circle. Okay, so both are within the circle. So they are. So the model is stationary now, but you also can check this one out, structure as well. Table, for example. So basically, it is not root, but inverse of the root. So this one just don't confuse. Basically, inverse of the root. But this one correct, inverse of the root. Okay. It is stationary. And then check residual, view, residual dynastic, congruent, Q statistic, just like before, and leg 12. So this one also adequate model. Okay. Plus P value less, P value greater than 0.05. Greater than 0.05 we reject. If less than 0.05 we do not, less than 0.05 we reject. Greater than 0.05 we do not reject the null hypothesis. Do not reject the null hypothesis. So if we do not reject the null hypothesis, that says the null hypothesis says that there are no autocorrelation. There is no autocorrelation within the residual. Okay, all autocorrelation are zero. So the model is adequate, and then you can produce forecast using the model. So just like before, forecast YF ER2 SE ER2 147 150. So let's use direct forecast. So you use static means that you are, instead of using previous forecast value, you use the actual value of Y per hour sample. That was static. Okay, so just like before, this is one forecast, 1 step 8, 2 step 8, 3 step 8, 4 step 8. Interval forecast, MAPE is smaller, but still not equal, 83%. So when you compare for performance, either you want to compare models, either you compare E-sample, AIC, SIC, or you compare the upsample performance. There also can be, you can use different strategy to select model. Let's say you want to select model by looking at the forecast performance, and you compare forecast performance. So this one you have forecast value YFAR2, which is given here, the last four I mentioned. the values before that all are actual value in sample. So before, prior to 9147, all are actual value in sample, observed value of y. Okay. But for this only this four is the forecasted value. One step rate, two step rate, three step rate, four step rate. And SE given here, SE R2. SE 1.09666. The R2 is one. Residual is very important. You can get residual from there. You estimate the model, and you can just get residual. So you can just get residual from here. Table residual. So the last residual I'll give you here. The last value of y, the last value of residual. 6376. So if you want to calculate manually, then you have to identify forecast equation. So in R2, just you have phi1 hat, phi2 hat. So everything in plus 1, so you get this one. You have everything in plus 2. Well, this one is the K times P. Everything in plus 2, you get this one. So meaning that instead of for our sample value of y, we use the previous forecasted value of y. Okay. So you calculate. You get this one for one step ahead, two step ahead, three step ahead, four step ahead. In terms of interval forecast, just use the same formula. Point forecast plus minus 1.96 times SE, you get this one, lower interval, 95% upper interval. Okay, number 5, if let's say if we just want to try to combine the two, but remember before the table that we have, the table on the theoretical ACF given in lecture 7, the one is the table, it was derived for based on the pure MA and pure AR model, not for mixed model. Okay, but if let's say you just want to try to see if let's say if we combine with the example to produce better forecast or not. But remember, basically, we are not combining simply based on the table. Basically, we just want to try. So we just want to try to combine that. But it's not, the model is not because of the based on table. But the table basically for the case of pure ME, pure AR. So estimate the model. So Y space C space AR1, AR2. MA1, MA2. Alright. Okay. So you have to check you correctly type it. Oh, C you get it on it because it's not going to be significant. It's going to be significant. Okay. So the previous one, AR2. So this one, you need to check for what? You need to check for both invertibility as well as station. It has both AR and MA. Okay, check both. So you go to view, Arma structure, table for example. So it is stationary as well as invertible. So both, specify both. Okay, and then in terms of residual elastic, leg 12, it is also an adequate model. Okay. Because we p value greater than 0.05, so we do not reject the null hypothesis. We say that there is no autocorrelation of order 1, order 2, order 3 up to order 12. Yeah. Forecast. YF ARMA 22 SE ARMA 22, and then range 147150. Okay. So this one better than, I mean the better. Yeah, 287 as well. So focus value, I mean just like before, so you can check that focus values given here. The last four values and then static error given here. Okay, static error of the focus. So to calculate the focus manually, you have to identify focus equation. Okay, and so using this to calculate. Okay, so this one in the Excel file, I only provide for the first for the number 3 and 4, number 5. So I leave it to you to calculate. You can calculate. Make sure you get the values. You get SE from that. From just now we have SE. We save SE. So we have SE ARMA 22. So you can just put it here. You calculate. Okay, calculate. So I leave it to you to do this one later. Because now already 45. I know that because there's a request to end the lecture. The idea for you to get past. So we stop now. Okay, so remember it's this Saturday, so we just a quick online meeting at 2 p.m. Later I will share a link. And please record attendance as well. If you have questions later, you can ask during that session. Okay. You can come. Done computer every